Okay, so this Sunday we're releasing GitLab 8.2, and GitLab 8.2 has a bunch of really cool features. Most notably, of course, GitLFS, but there's a bunch of other features, and I think it's important that everyone knows what they are and why they are. So today I will talk through them. These are the main ones. Of course, there's also a number of other changes and improvements. These are the main ones. So the first feature that we are introducing in 8.2 is the one that we like so much about Slack. So it's the award emoji. So this allows you to, in any issue or merge request, upvote using emoji. So just like Slack, you can add to any issue or to any merge request, you can add a number of emojis, and then if you want to add another one, you can just click on it. It's identical to how Slack did it. We had this idea quite a long time ago. And the reason is that what you often have in issues that people support and that people like, everyone just does +1, like we're used to. And then you get a really long comment thread with no information. So this completely mitigates that problem, and it adds a nice feature. And the cool thing about this is that this also will allow us to use this as a form of the feedback tracker. So we always use the feedback.gitlab.com to track a request and how many people like something. And this is the first step towards actually doing this in GitLab itself. You can just upvote things, and we can quickly see, oh, this has been upvoted a lot. So this first release, it will be still a little bit limited. So you can add any emoji. You can just give an emoji in your comment, and it will appear there. You can add one there, and in future releases, we'll add stuff so that it will be easier to see whether something has a lot, and there will be a search function for emoji, etc. By the way, if you have questions, interrupt me, please. The next big feature that we're introducing with 8.2 is releases. So in Git, you might or might not know, you can tag something. And a tag is like a label. It points to a certain commit. And the reason why you would use a tag is that you can easily make note of a certain point or make a certain release. For instance, in GitLab, we set a tag to a specific commit that we say, okay, this is version 8.2.1. And the nice thing is that you can just go, you can always refer to that tag. So you can say in Git, oh, I want to see this tag, and you're always pointed to the same commit. And this is really useful when you release software like GitLab itself, where that you want to share with people, because you can just set a tag for each release. But for some software, there's some more. You want, for instance, to have some notes with every release, or you want to, for instance, have some sort of an attachment to it because maybe you compile something with the code, or maybe there's some extra file people need or something else that you want to bring along with the release. So what we did is to tags, we added the ability to have a little bit of text, which is Markdown, which you've all been using, and the ability to add any number of uploads. So we already had tags. That is something that is native in Git. But the release bit, where you just add a bunch of text and uploads, that is what is new. And this is called a release. And the reason that it's called a release is because, well, it's like a release of a software, but it's also how GitHub calls it. And in GitHub, these are two distinct things. They work basically the same way, but they have separate pages for them, and we just collapse it into a single page. So you probably will get a customer asking, oh, do you have releases? And the answer is from 8.2 on, yes, we do. Any questions about this?
Yeah, what's a good example of how you would use, or say an upload and also comments or text? So I imagine that they're not the actual official release notes, right? They would be in the documentation.
You could use it for actual release notes, or you could have it as a glossary of like, oh, these are the major things that changed. So an example would be an application, for instance, a Mac application that you made open source. Mac applications come in a little package, but the source code is just like any other source code. So the tag that you would create would point to a commit, and that commit would just be the source code in all. But the little package that is the actual app, you could then add as an attachment. And then in the release notes, you could say, oh, this is release version 2 of my app. It does this, this, and this. This has changed. These bugs have been fixed. And so you have a whole release management system just in the tags function. So it's quite nice. Make sense, Hayden?
Yeah, so would it be the actual like compile binary would be the attachment?
Yeah, it's up to you. You can just attach anything. So it's okay. Completely free to attach anything. Like in any comment in GitLab, you can add any kind of attachment. You can do here the same thing.
Got it. And does the attachment actually go into Git?
No, it doesn't. It's just attached to this release, to this little extra data with the tag. It's not actually in Git.
Got it. So it's not as if you're checking a binary into Git.
No, not at all. No, and this is quite nice because these are usually things you do not want to have in your repository, but you just want to ship along with the release.
Cool. Got it. Thank you, mate.
Okay. Wait, so, sorry, one more question on that binary. I mean, if you do upload a file as part of the tag, where does that file live then? Presumably it's in the repository, but it's not being tracked by, it's not in the Git repository, but it's still, how does that work, I guess, that connection?
It works like any other upload. So it's just in the upload directory of your GitLab instance. So like any other upload in GitLab, it lives on your server or wherever you specified it, but it does not live in a repository.
Okay, thanks.
All right, so that's releases. Really nice feature. Has been asked for a lot for a long time. We always felt like, yeah, it's not a really big thing, but it made sense, so we added it like this. And I think our implementation is really nice because it's really lightweight, but it does exactly the same thing as GitHub. The next thing I discussed in the last lesson, so I'm just gonna quickly glance over it. It's a repository mirroring. Again, it's only for Enterprise Edition. Yeah, and I discussed it last time. So you should know what it is. And if you don't, go back. Another thing we added is global milestones. And this is not a really big feature in that it's mostly just an interface change to something that we already had, but it sheds some new light on milestones, which I think are not used very often in organizations and not very often on GitLab.com. And it is something that is quite powerful and will be expanding a lot in the future. So milestone is basically a way to, across projects and groups even, to see and combine and see the status of multiple issues and merge requests, many at the same time. Now, what we did in the past is we started with having only milestones per group, per project, sorry. So if you had a project, you could have a milestone. In another project, you create another one, but there was no connection between the two. Then what we did is we made it such that if you have a milestone in project A and you have a milestone in project B, and they have the same name, then if you go to the group or to the dashboard and to milestones, you could see that milestone as long as it had the same name between the projects, and it would be treated as one milestone with multiple projects. Now, that functionality we use actively within GitLab for our releases. So for instance, we create the 8.3 milestone for the next release in every single GitLab project. But it was a bit of a hassle to create it in every single project. So what you can do now is when you create a new milestone from a group, you can say which projects you want that milestone to be in, and it will automatically live in all those different projects. So it's a quick way to create a milestone that covers multiple projects within a group. Does that make sense?
It does make sense. The screen you're showing here, though, doesn't show the selector for the projects. Was that in a prior screen, or where's that?
No, actually, it shows it. You see under description, you see projects, and you see test there. Test is one project. And here you can just type the name of any project, and it will auto-complete the project. So you can just select them like as if you're adding a user to something. And you can have any number of projects there within the group.
Okay,
So it's
thanks.
a really small implementation. It's a really small change, but it sheds some new light on this, and it makes it much easier to use this over many projects.
Hey, Job, how many projects make up like a release for us, like let's say 8.2? How many projects repos are there, roughly?
A lot. It's
There? Yeah.
we have
I know
GitLab.
GitLab CI has one, right?
So GitLab CI no more, because that's now, so that's one less than you thought we had. But it's GitLab CE, GitLab EE, Omnibus, and then all the dependencies that we manage separately. So some are a part of GitLab, like Workhorse and GitLab Git. Others are not part of GitLab, but we ship them along, like the runner, for instance, which is also a separate repository. So I think all in all, to create GitLab of our personal things that we have our own repositories, it might be like 10, maybe less, probably a little bit less. If you take all the dependencies that we have, but we don't have a project for each, it's hundreds.
Right.
But of our own projects, I think maybe, well, 10, but it depends also on your criteria, because we have, for instance, repositories for our operations for GitLab.com that do not ship necessarily into each release, but a lot of the knowledge that is in there and some of the information goes into the other projects and has to be worked on to be able to release it. So I can't give you a straight answer to that, but I would say
that's okay. Yeah, I was just curious. Thank you.
So yeah, real quick. So an example of global milestone would be all of these features that you're mentioning that are going to be released on Sunday. These would all have like a global milestone tag for all of these projects, since it's across multiple projects, correct?
So we actually have a milestone, a global milestone, which is simply 8.2, and it has as date November 22nd. So you can see here November 20. You can see the date selector there, where you can set the due date. So that one we set to the 22nd. The title of the milestone is 8.2, and we just add all the projects in which we know there's that we have to do certain things before the release. So we would add the project GitLab CE, GitLab EE, Omnibus, and maybe some others.
Okay, perfect. And then everyone assigned to that project will see all of this.
Yeah, so if you are in any of those projects, you can go to milestone view, and you will see this milestone 8.2 there. So you can do that both from the group level, and then you see for all the projects within the group that have this milestone, you can see, okay, in GitLab EE, we have to do this. In GitLab CE, we have to do that. Or you can go to one of the projects itself, and you will see that this same milestone there again, but then only everything related to that project. So in GitLab CE, you will see everything for 8.2 in GitLab CE, all the issues and all the merge requests that relate to this milestone.
Thank you.
So besides these were the like core GitLab things, we also have some really cool changes to GitLab CI, which sound a little bit technical, but I want you to see this, and I want you to get a feel a little bit of how this works and how this looks, because it's really cool. So what we're introducing in GitLab CI, in GitLab, of which CI is part of, is build artifacts. And what build artifacts are is that when you have a CI process, when you have a build, it's possible that you have some sort of an output. One of the things you can do, for instance, with a build, take that Mac application that I was talking before. What you could do is you could, for instance, make that little package that contains your whole app, basically your app. You could do that in a CI build. Now, up until 8.2, at the end of your build, you had to put your result of that build, that output, you had to put it somewhere. And we didn't have any functionality to allow you to put it in GitLab somewhere. No, you had to like send it to one of your own servers, or for instance, to your Amazon S3 bucket, something like that. And that's not really convenient when you do this. So what we added is that the option to have an artifact come out of your build. And an artifact is one of these kind of outputs. And this functionality allows you to store it on your GitLab instance. So you don't have to worry anymore about where to store it. Rather, it's just stored with your build. And once your build has completed, you can go to your builds in your project, and you can just click download, and you have there your artifact, whatever came out of that process. So what you're seeing here in the screen is two little snippets. And the snippets are examples of how you would configure that in your CI file, in your .gitlabci.yaml file. The first one shows how you would typically do it, which is you say, okay, I have artifacts, and I want to store whatever comes out of this process that falls under binaries and the .config file. Does it make sense so far? Because it has to make sense for the next part.
Yeah, it does. Are these getting stored in LFS?
No, these are just getting stored on the server in a directory.
Okay. Actually, another follow-on question. So a CI build's typically smaller than, the compiled app. I'm just wondering because usually builds are quite large and typically you don't want to put them in Git, right?
So a build is a process. So when we're talking about a CI build or having something, it's just having something run on that runner that is connected to your GitLab instance. So when we're talking about a build, it's, for instance, running the test for your application. So for almost all of the things we do right now with CI, there is no output other than success or failure, right? This is the very foundation of the idea of having a build. You start a process, it runs whatever you tell it to, and then at the end it reports back success or failure. So you run your tests in there and they report back success or failure. Now, you have the option to do other things like building that app. And in that case, you have a whole process, the process that builds the app, for instance, that compiles the app. And then at the end, it spits out that app and that little package. And that can be of any size. There's no real restriction. There's no real rules about this. This can be several megabytes or this can be several gigabytes. So this is basically what it is. And because your runner, every time it starts a new process, it starts completely clean. You don't have the ability to store something there. It's not like it's a server where you build up things. What you want is that every time you run something again, everything else is the same, so that you are sure that that is a clean environment where you can just always run all your tests and it doesn't get affected because one change or another change comes in. So this is the problem we are facing. So what happens right now with these artifacts is that if you define this, that output that you defined, like that app, that little package that you have, it actually gets uploaded from the runner to the GitLab instance. And you don't have to do anything for it. You just have to define it in your CI file that you see right here, an example of saying, oh, I want to store this. And then GitLab itself will take care of all the uploading. And the only thing you have to do is press the download button in builds.
Job, maybe this is, maybe you've addressed this, but it's not entirely clear to me.
But I'm seeing you talking.
Oh, can you hear me now?
Still not.
No?
I can.
You can't hear me?
Yeah, I can hear you, Ernst.
Okay. Well, I'll ask you guys the question and you can relay it to Job.
Still not hearing you.
The question is, when the artifacts go back to the to your GitLab instance, do they go to the repository or not? That's question one. Question two is the paths that you show defined here, binaries and
I don't know if anyone else is, but I'm not hearing it.
Hey, Job, can you hear me? This is Hayden.
First.
Job, can you hear me? This is Hayden. Okay, I think Job's lost audio. Chad, can you hear me?
I can hear, yes.
Maybe I'm not hearing anyone.
Okay, can someone chat Job and mention he's got no audio?
I will.
Yeah.
I can hear no one. Hey, let me reconnect my mic. Can you say
Okay,
something
can you hear
now,
me?
someone? No?
Yeah. Can you hear me? No? Uh-oh.
This makes the Q&A a little tough.
Yeah, I'll just write it in a chat.
Don't
we
hear
go.
anything. I think mine are fine with.
Ernst, are you chatting with Job?
I'm trying to ask my question through the chat window. We'll see if he catches it.
I can hear you, but very softly.
But I don't see him responding to the chat in the first place.
Hey, Job, this is Hayden. Can you hear me?
He may not be able to see the chat either.
Okay, try again.
Job.
Oh.
I would suggest slacking then.
Slack. I'm going to Slack him in the sales channel.
All right.
I'm hearing something.
Ah, can you hear me?
Can you hear us now? There we go.
Yes.
Okay.
What happened, Job? What happened? We thought we'd lost you.
I don't know what happened. I didn't change anything, and I just stopped hearing you all.
Oh, man. It must be that cable in the Atlantic Ocean.
Okay, Ernst, you had a question.
Yes, my question was, well, I had two questions. One is, I guess I'm only just realizing the difference between things being stored in the repository versus...
I stopped hearing you again.
Oh!
I don't know. I think it's Blue Jeans. Anyway, I see it in chat. Do artifacts go to the GitLab repository? And I'll just answer that question.
Good.
They do not go to the repository. So the artifacts, they do not get committed in any way. They get stored separately. These are typical things that you do not want to store.
Okay. And then can you describe the paths more?
Yes, I'm hearing you. I don't know why. It's really bad. So the paths is just from the root of your repository. So what happens is that a runner picks up your repository and it does whatever you want with it. So it looks for that specific file in that repository, and then it runs all the scripts related to that file. So the paths are where it's going to pick up these binaries. So in this case, you have a .gitlab CI file. It runs all the scripts in there. And then by the end that it run everything, it will see, okay, what can I find under the folder binaries from the root of the repositories? And I take everything that is there and I upload it to GitLab. And I take that .config file and I upload it to GitLab. Does it make sense?
But so it sounds like you have to know what kind of artifacts you're going to have to make sure that you specify that you want to pick them up and store them?
But that's not entirely true, because so in the first example, what you're seeing is that we're specifying where the artifacts are. I mean, you should know what they are. You're not just going to randomly ship your artifacts. There's no reason to do that. So in the first example that you see with the paths, we're saying explicitly take whatever is in binaries and take that .config file, and I want those things to be the artifacts. However, and this is why I wanted you to understand this well, the second example that you see artifacts untracked true. This is an idea by Sid I heard from Camille, and I think it's genius. And what it does is that rather than saying, I want to have this and this as an artifact, what you're doing is, I want to take everything that is not tracked by Git by the end of this process and have that as an artifact. So your Git repository contains a bunch of files. The runner takes those, it runs all the processes that you specify it, and by the end, there are probably some extra files, like these things that are in binaries. And so what this option allows you to do is to just, rather than saying, I want to take the specific things from a specific directory, it allows you to just take whatever is not normally in the repository, whatever is new, what is not tracked by Git. Does that make sense?
And does it put them in the repository?
I see people shaking their head. I don't hear you.
Yeah, this is Hayden. Can you hear me?
Yes.
So when you specify, when it gets the builds or the artifacts after the process, does it check them into the repository?
No. So the artifacts are typically not things that you want to check into the repository. They are things that, like an app that you packaged or a certain output, and it can be wrong, or that can, you might need it for a later step, or you might need it for something else, but it's typically things that you do not store in a repository. That would bring other problems with it, because a build is something you want to be able to run as many times. You want to be able to have it go wrong. So you do not want this to influence the current state of your repository. It's something that is triggered. The build is triggered upon changes of your repository, and not vice versa.
So they're just stored on the GitLab server.
Yes, that's correct.
Yeah, this is a little bit confusing for some, maybe. Maybe just to clarify the distinction between the repositories, the Git repos, and the GitLab server. They're two separate things. So when Job says the artifacts are stored in GitLab, he means the GitLab server, not the Git repositories, which are on a completely separate file system. Does that make sense to everybody?
Yeah, Hayden, that's actually exactly what I'm learning. It makes sense, and I hadn't really paid attention to it. I'm kind of curious if Job can show us maybe an example of, I'm wondering, the repo that we have for the website as an example. I might imagine that some of the binary files that are there, perhaps the images, are not in the Git repo for the website, but perhaps they are. Is there a way, like, how can I tell, I guess, when I'm in a project, how can I tell where I am, whether something's in the repo or not?
Ernst, it's very simple. Everything that you see under files in a project, that is the repository. So the repository, a Git repository, is not as complex as you think. It's just a directory that is tracked by Git. It's tracked by Git because inside of it, it has a .git directory. You cannot see that because your file system by default hides folders and files that start with a dot. But that is all that is a repository. It's not that complex, and in fact, it's also stored on the file system in your GitLab instance. The distinction is that because it's tracked by Git, you have all this overhead. This is the reason why we say you don't want to put big files in your repository. So for things like when you're talking in issues with people, we store that somewhere else than in your repository, because we do not want those things to be stored in Git and saved to the history of the repository. The same that if you upload a file or an image to one of the comments, to one of the issues, that gets stored on the GitLab server away from the repository, because we do not want to version that information. That is ephemeral, that is not something we want to have version. So only the things that we explicitly want to version, we put in repositories. Therefore, build artifacts, which we should be able to generate en masse, they are not stored in repositories.
So, Job, can you hear me?
That's very helpful, thank you.
Perfect. Okay. So I think for me, the confusion is we keep talking about GitLab servers. So on premise, if we have a company, so company A, they have their own repository. They're going to have their own server. So is this stored on their server? So I'm getting kind of confused on this whole GitLab server thing.
Okay. For the next class, I'll make a really nice diagram, but I will explain it.
Okay, good. Thank you.
So GitLab, you put on one of your own servers. And GitLab itself is just, so that's your own server that has its own file system. And when you put GitLab there, everything is there. In theory, you can put everything on a single machine. You can put it over multiple, but then we're going in specifics. It's all a single server. So that means that on that single server, you put your repositories that are managed by GitLab, and anything else that you upload to GitLab, meaning you go into the application on gitlab.yourcompany.com, anything you put in uploads is also stored on that server. The artifacts that we're talking about, they are also stored on the server. It's just that the repositories, they are just in a separate directory from all the other things. But it's all on a single server, and it's on the server that you install GitLab the software on. So everything is on that same server. Does it make sense?
That helped me tremendously, yes.
Good. So do you all understand what you can do with artifacts and what you can do with the untracked ability?
I don't fully
One more
personally
question.
understand the untracked. Oops, sorry. Go ahead.
Sorry, go ahead, Chad. Well, go ahead, Chad.
I'd say the one that's not clear to me is that untracked piece.
So my understanding from what Joop and Hayden said on that is it's essentially any artifact that doesn't automatically go to that file system that's being tracked by Git.
Yes. So you have the repository. So you have a project, right? And a part of your project is the repository, and the repository is the bit of the file system that is tracked by Git. So Git has an index of everything that is there. That's the way you should see it. That's literally what Git does. It makes an index of everything that is in a certain directory, and it has a certain history. So when you run a build, things happen in that directory. So you might start off with only having a single file, but your build might be generating other files. So Git sees that you started with only a single file, but there are certain new files in the directory that it's tracking that are not tracked yet by Git. They are new, they are different. So what this ability does is it says, after build is done, look at the repository with Git, because this is what Git does, this is what it's made for, and see what are the new files, which files am I not tracking. And I want to take those files and send them to GitLab as an artifact. That clear things up?
For me, it's good. Yeah, much better.
Joop, one other question. So in the way the artifact paths are defined over there, it's where you pick them up from, right? So artifacts, paths, you go to the folder that's created that's called binaries, you pick everything up that's a binary. It doesn't specify where to dump it. Where does it dump it? Do you generate a folder in your project that's called artifacts, or where does it go?
So that is the nice thing. We handle that for you, so you don't have to worry about that. So in the past, this was the issue that you had. If you had some sort of output, you had to say, I want to put this here, and I do this and this. And in this case, you don't have to think about it. What we do is we store it on your GitLab server, but you don't have to think about this. The only thing you have to do is you go in your project to builds, and you press download, and you just get the artifacts of that specific build.
Yeah, question. So what is the main benefit of having the artifacts get pushed to GitLab? If you could provide an example or some sort of thing, like if we're talking to clients and talking about this feature, what is the main benefit they're gonna see out of this?
Sure. When you have a CI, you want to have the ability to have artifacts. That is something that is it's a fundamental part of having a CI run. So this makes it much easier to manage those artifacts. You do not have to set up anything external to manage these anymore. And in future updates, we'll add even more advanced functionality that, for instance, allows you to pass artifacts between builds. We'll discuss that at the time. For now, the advantage is that you can manage artifacts very easily. You don't have to worry about it. It's right there in GitLab. You don't have to think about where to store them, what to do with them. You don't have to manage credentials. You just say, I have artifacts, please store them for me.
So, yeah, would you recommend, is that a question, is that a discovery question we should ask in the process? Like, are they storing artifacts? And if they are, then we should talk about that feature.
I think that's a good question to ask. A lot of people are. There's a famous program from JFrog called Artifactory that is used often for this. People that run relatively complex applications, they use this quite intensively. So this often happens.
Okay, so we can assume most people are probably using this, but it's a good validation question to say, assuming or if you're using artifacts, one of the features or advantages of GitLab is it all sits within the GitLab instance.
Yeah. Okay. In your CI, that's the idea. It's always within the CI, right?
Got it.
All right. So the next one, similarly challenging, and that is the ability to cache within your runner. So as you now know, to have a CI run, what happens is that a runner grabs the repository, and it does something with it, something that you specified. Now, for instance, if you have GitLab and you want to run the test of GitLab, we have a lot of dependencies in GitLab. So every time a GitLab build starts, what happens is that the repository gets copied and all the dependencies start installing. But that takes a lot of time, and time is money, and no one wants to spend a lot of time, and you don't want to wait for your builds to complete. So what you can do is you can cache certain things in your build, meaning that in my example where we have to install all these dependencies, what we can do is we can simply cache the result of that installing so that that doesn't have to happen, so that the next time you do a build which has a similar dependencies, the dependencies are already there, the runner will see, oh, I already have those, and it won't install them, or at least the script that installs them will see, oh, these are already here, I can skip this. So this means that your builds can be much, much faster. So before I start asking questions, the example that you see here is RSpec is just a type of test, one that we use, for instance, for GitLab. And what we say here is we want to cache everything that is not tracked. So this is the same as the last time. I think I heard someone trying to ask a question.
No,
So,
this is
yeah, go ahead.
this part's actually pretty good for me. No, I didn't have a question. I was just, I guess, when you describe that the runner grabs the repository and starts building the dependencies, what is there a visual? Is there a further explanation you can give on what that entails? So I guess
Sure.
that depends on what kind of code you have and what kind of compiler you have, or what. Yeah.
Now let's say you have a folder. Your repository is just a directory, right? And before you can run a certain test, you have to install a little script that is there. So there's a little script in your repository, and you have to install that before you can actually do the test that you want to run. And at installation, what it will do is it will put files there. It will put files in your repository, because that is what installing is. It just puts file in a certain location. So what you can do, and what you can do in this example, for instance, what you see is that you can cache, so you can store those things that it installs, those files that it puts in the repository. You can store them for usage in the next build, so that the next time you do the same build, after the first time it's been installed, the installation script will see, oh, these files are already here, I can skip this whole part. So that entire duration of that installation, that is then skipped. And this is what caching is. It is using data that you have retrieved, that you have generated before, reusing it, so you don't have to go through the process of installing it or getting it from a server somewhere. To clarify things?
Yes, I understand the value of caching. Yes, thank you.
So, and again, here we have the option to do this with untracked files. So rather than saying, oh, I want to cache a certain directory, I want to cache certain files, you can just say, I want to cache everything that Git is not tracking. Therefore, everything that changes in the repository after it's done doing the whole build, I want to cache everything for the next build. This is an extremely nice way to add some sort of caching to your application, because in doubt, you can just add this, and if the runner sees that there's things cached, it will make use of that.
Now, this is a feature that has to be implemented by our customers, right? This doesn't automatically happen. So it's extremely valuable for people using GitLab to know about this. Otherwise, they won't be using it, correct?
Yes, this is something that, so what you're seeing here is a part of the .gitlab CI YAML script. So if you put in your script somewhere, cache, untracked true, you have this functionality, but you have to do that, of course. The same goes with the last option, by the way, with the artifacts. But this is something we have to market, we have to document really well, etc., etc. it's something that people will look for, because this is one of the things that, for instance, the famous CI, Travis CI, has had for a really long time to make sure that builds happen quickly. They spend less CPU cycles for each build.
Perfect. Thank you.
All right. If there's no more questions about this, and as always, feel free to ask me questions about this anytime later, because I know this is really complex. But this is really worthwhile. This is really interesting. Like, this caching is quite a big deal. The artifacts is a very big deal that we will be expanding a lot on later. And it's like really core parts of our CI product, and something that people expect from an advanced CI tool. So this is something that we'll get back to later. We'll expand on. We'll make. So it's important that you understand it well.
Joel, do you have some data in terms of time saved thanks to the caching, that kind of thing, that would be helpful for the sales team?
If it would work today, I would have told you. No, I think we'll deploy it in one of the coming days. So this is not, we don't have any data on this one. Next one. Oh yeah. I couldn't resist adding the one more thing line in here. Of course, as you know, we are introducing Git LFS with this release. We release GitLab on the 22nd, so that is Sunday. But we want to market this extra. So Ashley has been in communication with, I don't know who. So the actual LFS announcement and the fact that it will be in 8.2 will only be Monday. So this is important for you to know, and that's why I didn't even add it here, because this is all public. About LFS, it is on by default. I will discuss with you what it does, and we'll maybe go into it later more. It's on by default, so that means it will be available for everyone. Our customers all have their own servers, so they do not have to worry about things like gaps and such. It's an extremely powerful feature. I think it will be really, really popular. Of course, in this release, it will still be in like a beta state, so things will be broken, but we'll fix them. I started using it for university also today, and we found some bugs, small bugs, but still. And I think it's really exciting. So I already discussed it more. So if you have questions about this, let me